Hello and welcome everyone. Good afternoon, morning, evening, whatever it is for you, wherever you're joining from. And welcome to our live stream today. My name is Michaela Woods and I'm a developer advocate at KX and I'm going to be your host for today's session. And it's going to be all about diving into the world of quantitative research and learning how specifically KDB Plus plays a vital role in driving analytics there and decision making in a modern finance stack. And I'm super excited to be joined by today's guest, Emanuele, who is a leading expert in this space. So welcome to you. If you want to say hello.
Well, thank you very much for having me, Michaela. I'm excited to be here today and to talk about KDB, as it happens, and quant research. Been a long time fan of the technology. Fun enough, that's how I started my career in data engineering. It was really with KDB. So I've had lots of fun with it throughout the years. So happy today. We're going to be talking about some of that and how KDB really is one of the best technologies out there for quant research.
Amazing. Yeah. And for those of you who don't know, Emanuele is the principal data tech lead at Talos currently, and he oversees the development of their data platform there for lots of different institutions. And he's got over a decade of experience in the KDB Plus community as well. He's also a really big thought leader in the space, really active contributor in the community, both online and at events. So we're so excited to have him today. And you really are the expert. So I'm going to be learning alongside you with all of our attendees today. So I can't wait to get started. But before we dive into the fun stuff, I just want to mention for anyone watching along live, please submit your questions. And you can do that just using the chat, either on the StreamYard link from where this is streaming from, or if you're watching on YouTube, you can submit them there and we'll see them. And we might have a mixed audience here. Some of you guys might already have experience with KDB. Some of you might have experience in the quant space, but not so much with KDB and are keen to see how it can work there. So don't worry, we'll tailor this for everyone. But do comment if you want to let us know your experience level so we know who we're talking to. And the conversation is going to be driven by the engagement we get and the types of questions. So if you want to go more deep on a certain topic, just let us know and we can certainly do that. Secondly, this is being recorded and will be available on our YouTube channel straight afterwards. So if you have to leave or you want to share it with any friends or colleagues who you think might find it interesting as well, that will be there straight away. Okay, so I think with that, we're going to get started. So I'll just bring up our slides. So before we get into the technical stuff with Emanuele, I did just want to provide a brief introduction at a very high level to what is quant research to kind of set the scene, maybe if we have people who are joining that aren't as familiar with the financial world. So I'll just move my slides on one here. So yeah, let's start with that. So I'm going to start saying quant research instead of quantitative research because it's a mouthful, but same thing. And it's basically just a data-driven approach to understanding financial markets, using statistical models, mathematical techniques, and basically huge amounts of data to make trading decisions and to analyze market patterns. And at its core, it's all about turning that raw market data into actionable insights. And it can involve things like predicting stock prices, identifying different trading opportunities, or managing risk. And typically you're using historical data and real-time data and statistical algorithms to do that. And the key thing with it really, it's based on hard data, not just intuition, like maybe other trading. So people and analysts and different quant traders will build strategies to test them with historical data and automate that process. So the role that KDB has played and historically has played is a big one in the space. And as many of you probably know, joining today, KDB Plus is a high performance time series database and system. And it's widely used in financial markets and investment banking as well, and especially for real-time data processing and large historical data analysis as well. And Emanuele is going to go into detail on what and why KDB is so effective in quant research on specific use cases. But I did just want to touch on, at a high level, a few standout areas that it does well in and why it's been chosen historically for so long. And one of the main reasons for this is during the data ingestion phase, firstly, KDB can handle vast amounts of data, and it can process as it arrives in real time. So it makes it really easy to do things like adding new data sources, scaling up, ingesting, streaming data from lots of different places and lots of different formats really fast, performing updates on the fly, and making that very performant to work with as well. The next stage then would be in the processing stage. So once you have your data ingested, what makes KDB unique is that you can actually have the same structure for both your real-time and historical data. And in other applications, or for maybe some people not using KDB, they would tend to need one technology for the data storage and another one for data analysis. But with KDB, you can do analysis directly on the data, no matter which type it is, and it's all in one location. And some reasons behind why it's so performant includes things like the small memory footprint of the software, how it does memory mapping, and the parallel processing capabilities are behind that. And then lastly, the third phase then, once you have your data ingested and stored, then you have your analytics and your insights, driving your insights. So what am I actually going to do? What decisions can I make based off this? And KDB allows really fast querying, really fast data aggregation, really fast joins and stuff like that. We'll go into that in more detail in different aspects of quant finance there. And I think the main takeaway from this slide was basically there's lots of other technologies out there that do some or maybe many of the above, but none really combine all of these capabilities together in one platform. So yeah, today is all about letting Emanuele teach us and help us understand just how powerful KDB can be in several of these key areas. Do you want to add anything here at a high level before we dive into the specific topics we have lined up? Maybe give us a view of, your experience of it and how it's helped you in the world of quant finance. Or are we all good? Can you hear me? I think we might have. Oh, sorry, Emanuele.
There we are.
No, oh no. Okay.
It's all good. It's all good.
I'm not sure if you were there at the beginning or you just dropped when I added the slides to the stage.
I think my connection might have dropped, but
okay, cool.
I heard the tail end of it, and there isn't much to add there because you've summarized it quite well. And look, in my experience, what I've seen really resonates with what you just described, which is if you're looking for a single stack piece of technology that can do all of it, then KDB is the choice. And it's been proven by the fact that it's been adopted by the industry for almost 25 years across almost every single institution that does it, right? And I think you can speak with people that have used KDB and they will confirm that if you're looking to do things in a certain way in a single stack, both historical and real time, KDB is the de facto standard in the industry. So really excited to go more into detail here with the conversation. So let's go.
Let's dive in. Okay, cool. So we're going to start with one of the most common applications and aspects of using KDB Plus in quant research, which is transaction cost analysis. I'm just going to take 2 minutes to explain transaction cost analysis, or TCA, for anyone who may not be familiar with the term, especially for any non-quants or non-financial folks in the audience. So TCA is basically used to evaluate costs involved in trading. And when you talk about that, it's referring to explicit costs, which you think of naturally. So like fees and commissions you're paying directly. But then secondly, and less intuitively maybe, is the implicit costs. So that includes things like the market impact and the slippage. And we have some definitions of what they actually mean, but I'll just explain it very quickly. So slippage refers to the difference between your expected price of a trade and the actual price of what a trade is executed. And that can be due to different factors like the market volatility changing or liquidity constraints. So, for example, you place a buy order expecting to purchase a stock at $100, but by the time your order is actually filled, the price has moved to $101. So that $1 difference is the slippage. And then market impact refers to the effect that your own trade that you've placed has on the price of that asset. So say, for example, you place a large order of like 10,000 shares of a stock. That's going to create a buying pressure from your order, which will push the stock price higher as your trade is executed. So then you end up paying more for the later shares. So just the difference there is one is to do with external market conditions, so that slippage, and then market impact is more about how your own trade can actually move the market price. And both these things are really important and can have a huge impact. And if you can handle how to reduce these, then you can make obviously big profits. And minimizing those costs is really what all this TCA analysis is all about. So Emanuele, do you want to talk us through how KDB Plus is used in TCA and what makes it so valuable for this analysis in particular?
Oh, absolutely. So two main components here you've touched on TCA is first of all the market data and your execution data, because you want to analyze a trade in the context of what the market is. And there's a reason in why that's KDB a good technology is that first of all, the amount of data that you would use from an historical perspective to base your TCA analysis off, it's found in the same place that you would find your real-time data to do the same analysis, right? So you'll just find it all in the one place from an architecture perspective. Now, from more of a technical perspective, what the language actually has to offer is a number of functions which are really suited towards time series analytics. So for example, the as of join, which is a very established function and functionality in KDB that allows you to find the prevailing quote at the time of the trade. So if you were to look at what your actual trading price was based on what the market is, then as of join will be the function that you use in finding what the market is at a specific time. And there's other ways than some of the functions that exist in KDB, which are really math or statistically oriented, as many people say, are native for the type of calculation where you are just doing the deltas between some trades and the market at that time, or where you are projecting. So it's the tool set that exists within the KDB native function namespace is really helpful for doing this type of analysis. And it's been also optimized over the years, right? There's functions that are now natively multi-threaded. There's functions that give you exactly some of the things that you're looking for, like, for example, the VWAP. There is a built-in function to calculate trade VWAP price, whereas in other places you would have to go and calculate your own size, time price, divided by yada, yada. Here you would do it with a native function. And the syntax in which you would do it, I'll sound like a fanboy here, but the syntax in which you would do it, it's very concise. And in little code, there's fewer chances for bugs and errors. At least that's always been my motto. And you could see this, you could see why then KDB is really used for the TCA space by teams of Quant. And it really falls into a very expressive language where with a few lines of code, you could do a few things, and those things are exactly what you need to do, like finding the time, finding the quotes at the time of the trade, or finding a VWAP calculation and doing a delta between your expected fill price and your actual fill price.
And it's interesting you said there that you can calculate things like VWAP or whatever in much more concise code, and that reduces issues or problems. I don't know if we'd have everyone on the call agreeing with that, but I think you can see here some examples of that calculation and what it looks like. And I guess, do you ever come up against opposition from maybe new clients that aren't exposed to this before? Like, what are people's reaction? Is it like, when people say it has to be concise, I think sometimes people can think it's like it's scary or like it's very obscure code. But I think you can see here from the simple commands that we have, it's actually quite intuitive. Like, there's a language called QSQL, which is actually a lot like SQL, and it's people think Q and KDB is such a scary thing, but I think that's a little bit of a misconception sometimes. What are your thoughts on that?
KDB can be scary, can be quite scary. Absolutely. As can be any other code base, honestly. It would really depend. It would really depend on what you're trying to do. There are certain patterns that are established in KDB, like in many other languages. So once you understand those patterns, right, you wouldn't necessarily have to parse every single letter and symbol in the line of code that you're looking at. You know already what's going to happen. Like you understand the pattern, you understand how it's been done, and that's true, I feel, of every other language. There's patterns in every language. Just that, for example, the ones that are mass adopted, you would have more examples, you would have more people understanding that compared to maybe what's KDB. So for people who are looking to buy in KDB, sure, the syntax is scary. There's lots of symbols, but at the same time, that's all there is. And you can see here from the 2 slides.
Yeah, it's not as scary as maybe people might first think. And we do have one question here from Max. He's asking, can one model slippage and market impact with stochastic differential equations in KDB?
That is a good question, Max. I would have to say it would depend on the type of equation. I'm not familiar with the stochastic differential equation that Max might have in mind. Possibly, maybe. So that could be one for another. That could be one for another conversation on how to.
Yeah, we'll follow up in the comments on that one with you, Max. That's a good question. Anything else on or for TCA? I guess is there any custom KDB scripts or workflows that people should typically follow, or maybe someone who is looking to improve their TCA analysis? Like, how would you recommend they get started doing that? I guess I've kind of led into it here with this slide, but we do have a white paper. I'm answering my own question here by Colm Early. It's on our website, and I'll put all the links to the white papers in the comments after the call as well. But yeah, did you want to talk about like how someone could approach using this and stuff?
Yeah, absolutely.
The next level?
Yeah, I would say, without getting into the merit of the TCA methodology and what actual models you're using, the type of data and the data modeling that has been chosen to perform the analysis can really change and impact the performance of the analysis itself. So, for example, for somebody who's just looking to copy paste the code from the paper into a terminal and run it, right? There might be some things that they could look into, like, for example, we're seeing an AJ here, which is the as of join, that we know it uses certain columns in a certain way and does need some attributes to be applied to the tables in a certain way for it to perform very, very well or very badly, depending on how that's done. But that's in the merit of the technology more so than the model itself.
Yeah, so someone could pick this line of code up and have a bad experience with it if they're not fully, got the background that, there's some considerations that you need to take in place. But I think that's well documented in this white paper as well. So, there's a good starting place here as well to go from. Do you think, from what you've seen, like different firms and banks are making full use of like the data that's available for TCA? Or do you think there's areas where if they had more data, it would improve their analysis, kind of, anecdotally from what you've seen in the field?
Yeah, so it's
just limited to TCA, I guess, that question.
Sure. I think more generically, it's a mixed bag of usage. You would have some installations where KDB is more used towards the real-time pre-trade type TCA, and some others which are more geared towards after the fact TCA. So those are very different use cases, and KDB is good at both in its own ways. One, we're doing real-time trading analytics, and the other one is when you're actually doing big HTB type calculations on your historical data. But at the crux of it, it's always the underlying data that is what makes or break it. You need to have good market data, obviously, to fit in the models. You need to have good trade data. You need to have all the ancillary data sets that you will need for this analysis. And one application where I've seen KDB doing very, very well is next to real-time trading engines, given the low latency requirements and given how the low latency of KDB, given the low latency that KDB can operate at, it's not uncommon to see trading engines connecting to KDB processes directly and communicate to each other and exchange data based on what the output, the exhaust of the trading engines is, going to KDB, and then use KDB to calculate some sort of decision that the engine has to perform. Now, obviously, we're not talking about super low latency FPGA trading, like, for example, FX arbitration, right? We're not talking about that. We're talking about more so trading management and risk control. But it's very common to see KDB there. And the main data sets is the market data, right?
Okay, yeah, that kind of leads us into our next the next thing I want to talk about was just market data more generally across quant research. And like what you said there, I think most people, are now agree with this statement that the backbone of any model you build is all about the data, the quality you have, do you have the right frequency and amount, and if you need historical data, do you have enough? Is the quality good enough to be able to actually develop strategies that are going to be profitable and reliable? So yeah, the ability to analyze all of this vast amount of data is really essential, and I think you've touched on it there, but outside TCA, what other challenges maybe have you encountered with market data, and maybe people using other technologies that you've seen, and then where does KDB really come in and help in those situations?
Yeah, so I would say the challenge with market data, it's usually it really depends on what asset class obviously you're operating in, because some of those could be more volume driven, some others might be more latency sensitive, some other might be a mix of both, right? So
okay, give us an example of different, like what would be more volume driven. And
oh yeah, so sure, for example, if you were talking about options, for example, right? Mm-hmm. It's a lot of volume, it's a lot of messages, it's a lot of rows in your tables, it's a lot of quotes. Now, depending on whether you are in the US and in Europe, it might differ because of regulations of how they are actually handled, but it's generally speaking a very chatty type of asset class compared, for example, to equities, where you wouldn't see as many messages per second coming through your plant, but you would see lots of symbols, and you'd have to deal with books in a different way. For example, compared to FX, whereby, touching on the FX arbitrage that I mentioned earlier, you would need super low latency FPGA type hardware to even be able to play the market, right? So there are different challenges depending on which asset class you are operating in. But from a data analytics perspective, when it comes down to then analyzing that data, I've seen KDB applied across all of those, both in the option space with petabytes worth of HTB as opposed to equity space or FX, where you're still doing data analysis. And in one case, you might have many tables, which are tall and skinny. In some other cases, you might have shorter table, which are actually pretty wide. And one very common use case is when you're looking at decision data that is coming out of a trading engine. The message that comes out of the engine would have a copy of the market data that the engine has used at the time to make the decision. He would have a copy of so many more attributes that then are used for research and best execution as well, right? So really, the engine is trying to come up with a message that gives you the context of the decision. And so you end up with, it's not uncommon to see 500 columns in the table for that entry. So it really depends, right? And why it could be good for KDB in there is that when you have, obviously we all know tall and skinny tables, it operates very, very well. Mm-hmm. But at the same time, when you have a very large table, given it's a columnar database, you can actually slice the data in a way that it's still efficient by keeping some columns in memory, by keeping just some other columns on disk. There are patterns and constructs in which both can be very optimal, depending on that. Which also means that then data quality can be applied in very different way. You can go very efficiently by column, and in some other contexts, it wouldn't be as easy to scan the columns as quickly in a single place.
Interesting. And have you seen that maybe people experienced in one asset class, or developers tend to, they know how to handle one way and then you come across like a different asset class, and the same thing doesn't apply. Like there's a need to tailor there, and maybe it's not as. I think one of the challenges with KDB is, it's kind of like you can do anything with it. You can, like you said, other databases might be constrained to just have one of those types of data sets, but with KDB, you can have, many different forms, and you can have it performant across tall, skinny tables and wide tables. But you really need to, understand that it requires different attributes or different settings and stuff like that as well. But yeah, is that something you kind of seen it out there, that people maybe they know how to deal with sims in one scenario and not in another?
It might have been the case before the Python KX integration. Probably was more of a pain point back then.
Okay.
But I found that since that is available, it's become very, very much transferable, right? So what people might have written in Python to do some research in one place, then all of a sudden gets shipped across, because now you have PyKX that can allow you to do the same. If we want to get into specific analytics, for example, that might be very useful in one case or not in another. If we go back to what is the volume in the option space, for example, one common use case is calculating the top of book across all the exchanges. So given the feeds are very, very chatty, they might get throttled. So even when you get the messages from the exchanges and the market data, they might not be representative of every single tick that happens. And I've seen KDB used to recalculate what actually NBBO looks like across all the North American exchanges in just one process, and doing it pretty fast.
So, I mean, KDB is the answer to everything. But no, it's like, to be serious, like, would you say, I presume KDB alone isn't enough. So I wonder, what do you think the other technologies that you use or rely on in conjunction with KDB to really enhance, your overall market data capture and analysis are? What things would you switch out KDB for something else or integrate it with in which places?
Yeah, so sure, you can integrate pretty much any mainstream technology using the Fusion interfaces, right? You could write a C++ binding and just have it loaded in your KDB process and use that to process pickups file from an exchange, for example, right? It's not uncommon to do so. It's not uncommon to see Golang bindings that are then used to exchange data with KDB to then be pushed somewhere else. It really interfaces. Although we often speak about KDB being the one-stop solution and just having everything there and cannot be taken away, the fact of the matter is you can actually plug in so many other technologies, and you can literally choose where you want to go with those, as long as it fits within one of the Fusion interfaces, which comes very handy depending on what infrastructure you're putting KDB on. It really focuses on solving that use case that KDB is good at, and interface play nice with the other technologies for what then is needed by those.
Yeah, and good shout out to the Fusion interfaces. And if you're working with them, or you'd like to see them enhanced, or maybe there's other interfaces you need, like, do let us know through like our Slack channel and stuff like that. And we'd love to know how people actually out there are using them and examples, and maybe we could reshare those and reshare that knowledge as well. I think that would be a great topic for a future live stream as well. Seeing some of those integrations in action. So yeah, I think you did mention options a few times there, which was again foreshadowing the next topic. Before we jump into that, though, I think we were going to just shout out this here white paper, which kind of is a good example of how market data can be used in conjunction with KDB to really do some nice, really neat and fast calculations. Do you want to talk a little bit about this paper, maybe?
Yeah, so this is a very good example of what we spoke about earlier, in that you can just have something very simple and effective within one simple stack. In this case, James Galligan here wrote this paper to show how easy it could be to write a MACD indicator for a stock, right? The MACD indicator is actually used quite widely within the trading industry by traders, pros and professional traders and non-traders, actually very well known as to be one of the signals to go often when somebody's doing an analysis as to what they want to trade. And here you can see how this is done. For those in the audience that are familiar with Python, I'm sure you've seen this also written in Python and know how it looks, which is not 7 lines of code. It's a few more. Now that comes in for the fact that, as I mentioned earlier, there are some built-in functions within KDB that really allow you to take advantage of that.
We did have a comment on Max to that effect, echoing the same sentiment there, that the terseness makes it a better like language than Python, which can also be terse on occasion. Anyway, carry on. Just wanted to pop that in.
No, that was well timed. And so, like in this case, for example, one common use case could be in the tick architecture. You would have your tickle plan feed into CEP, complex event processor, whose job it is solely to calculate the signals based on the streaming data that is coming in from the market data captures, right? And then this data could be then adjusted using data that is coming from the HTTP that gets pre-calculated in some other ways. But this is a very classic and relevant example in one of the KDB applications. This is not just academic type white paper. This is actually real life scenarios.
Yeah, and there's lots more in that paper. I think there's like over 10 examples of different functions. So yeah, awesome. So I think we'll move on to option pricing now. I think this is quite a meaty topic that we want to get into. And you mentioned already that with the options asset class, one of the key things is the volume and the huge amount of rows. But I do just want to, I know we talked a bit about KDB and option pricing. I am just going to give a quick introduction to options. I'm sure most people on the call probably know what they are. But they basically, trade like a standard instrument, but they're actually just a contract allowing traders to speculate on the price of an asset. And they're much more complex to price and to be profitable off, but there's also a bigger risk and then bigger reward as well with them. And the different factors here are listed that can influence the option prices. And it's not a simple, straightforward calculation. And some of the traditional ways that this is done are things like the Black-Scholes model. And that's saying that you're assuming your market has constant volatility. Sorry, you have a smooth market and constant volatility. But that in practice isn't really solid enough. You need to have more complex models as well to take into consideration when the market isn't smooth. For example, here obviously the volatility of the market will decide if my future price of my option is going to change or not. So yeah, the fact that markets move so quickly and that their traders need to price all of these different options on all of these different scenarios, and then also accounting for noisy data and the need for recalculating and redoing the computations constantly. This is like a classic use case for KDB really, and one where it really performs well. So yeah, do you want to talk a little bit about this? And I think you've touched on it already, but maybe we'll go a bit deeper onto like options specifically, and when you're trying to implement models for these pricing algorithms, what are the biggest challenges faced by traders?
Yeah, I would say once again, there's two things. One is the volume of the data that you're dealing with. Depending on where you're looking, if we're talking about, for example, the US market, it's actually billions of rows every single day. And if you're starting just from what is called public market data from the Opera feeds, right? So, and if you start thinking about historical analysis there, those numbers build up pretty quickly, right? Even if it's just single-digit billions every day, in a month you end up with a massive quotes table that needs to be split across multiple symbols that you need to shard. And so one of the challenges there when you're actually modeling that type of architecture is how do you want your trader or your quant really user experience to be in that? Will they have to go in and get the data from every single instance? Because of that volume, you'll be bound to shard data across multiple instances. And then would you let the users deal with it? Would you build abstraction layers and APIs that help the users and that so that they can focus on what is their actual job, which is the quant research, right? And the pricing, for example, that you just mentioned. So that's from a data engineering perspective in KDB, that when you're talking about options, that is one of the challenges more so than other asset classes for sure. And from an option pricing reference, you mentioned some of the elements like vol is likely the main thing they will be looking at, and calculating those metrics. It's an easier job in KDB than other technologies because of how conducive the technology is to what is effectively statistical and mathematical modeling and functionalities that then you would use in that type of analytics.
Yeah, I think we actually have an example of some of those calculations from another white paper by Deanna Morgan. So she's got some of the Black-Scholes option pricing example, and also some variations on the Monte Carlo one. So that you can see how they've been implemented in KDB and Q. And I definitely would recommend checking out that white paper. It's got some really good steps and examples there as well of how that's actually happening. And you mentioned the data engineering aspect there of KDB, and obviously the volume and the historical side. So with options trading, is it more about the historical analysis side, or does real-time trading, like how does that come into it? Is that important as well?
Oh, but very important. Absolutely. Very, very important. You want to, when you're using your options, when you're trading options, you really want to be in the market at the right time, at the right place. And there's value in knowing when to get in and when to get out, more so than other asset classes. Now, I'm not a trader by profession myself, right? So this is not financial advice. I feel like that has to be said. But
disclaimer.
Yeah, exactly. But in any case, there's strategies in the option trading space whose purpose is solely to understand when to put in a quote in the market for an option and when to go down. For example, if you think about market making options, and having real-time analytics allow you to do so. You have to be pretty quick. You have to be making those decisions very, very quickly. So personally, I've seen both the KDB application doing so next to some other Python applications doing so, and they perform very differently. So okay. KDB, when it comes to the real-time streaming aspect of it, it's, in my experience, has always been the factor of choice because it offers you the best performance when you're trying to do that. But also, again, as I mentioned earlier, is having all of it in the one place for your quants to write the analytic function in one language, and then being that applied across real-time and historical data, so that they don't have to write different queries for real-time and for historical, right? The table has the same data modeling across. So the API and the function is the same.
And when you've seen that, you mentioned there, you've seen the Python version doing option prices next to the KDB version, and obviously KDB was able to handle the real-time element. Was the Python version connected to KDB, or were they using, what was it looking like? I'm just wondering now with PyKX, would that make that easier maybe for some Python users to get the real-time benefit without having to switch out of, the place that they're used to working from?
You would definitely see more Python business logic being run by KDB backends.
Yeah. Okay. And
there is a trend.
And would you sometimes advise then, hey guys, if you switch this out, you put your analytics in Q or KDB on top of this, you're going to get so much better performance. Yeah. Or not necessarily always needed.
So we'd have to go back and thinking as to what are we using KDB for, right? Which is, and in this case, like if we're doing real-time streaming analytics, you'd want to be as close to the technology as possible. And I wouldn't advise you to implement that in Python and stick it into a KDB process, right?
Yeah.
If you don't need that, you don't need to spend time on that translation. If you're trying to do, even if the computer is going to do it, it's going to be fast for sure, but you don't want to add that layer of latency then to the application and just do it in KDB. If it's historical analytics, I think it's an open field battle, right? You would always have some people who prefer using one language as opposed to go native. In my experience, going native, you'd always get the best performance. And so I tend to steer towards that. Now, find experiment in Python, fantastic. Same in KDB, right? You could do it in both languages, but I find that I always try to steer towards writing the KDB native code when it's actually going to production, so to say, because of the reason that we touched upon earlier, like better performance. Obviously, the code is very different, but it's in short code, there's less bugs, and the other reason that we spoke of.
Yeah. Yeah, so maybe your traders or your quants are writing their analytics in Python, but before we, put them into that trading system, the translation to Q might actually.
KDB,
yeah. Nice, very interesting. If anyone has any questions on anything we're talking about, do ask them, please. I think we've covered a lot there, but do you have any opinion on maybe how AI and machine learning might impact the future of options pricing, or do you think it's not relevant, or what's your opinion on that? And maybe even you can open it up to talk more broadly around quant research.
I've actually never thought about it in that way. If we're thinking, how will machine learning AI impact option pricing and research? That's a very good question. From what I've seen until now, the maturity of the pre-built models and the type of data that they operate on still has some way to go. Not to say that you cannot do it. You can certainly do it, but it requires a very high degree of specialization in both the machine learning aspect, in the infra aspect, because you have to have an infrastructure that can support those models. And then you need to understand the data very, very well. I think if you're thinking about it in the optics of, will we have a ChatGPT-like option pricing experience? I think we are few years away from that, but you definitely start to see machine learning being applied to these use cases.
Interesting, yeah. And I think, do you think that the quant research field has evolved a lot? Maybe if we look backwards instead of forwards, from when you started out, or especially in relation to the choosing of technologies, or is it been quite stable? What kind of changes have you seen over the years?
So it's when I started, I would say there's definitely been a time between, I want to say 2010, 2004, even 2015, when quant research teams were looking for that next tech that was going to blow the field away. Then there was the realization, I want to say 2015, 2018, what I've seen that really slow down. I've seen that actually there really isn't another technology. Like we already have two technologies, right? That could do the same. And one is KDB, and the other one that is evolving, which is Python. And we can just use the two of them together. If you're more of a Pythonic user and that's your choice, that's fantastic. You're using KDB. If you're more of a KDB user, then it goes both ways, thanks to the PyKX plugins and everything that was, all the work that has been done, the diffusion interfaces. And then that has almost left out the SQL-like users, which is the people who prefer to use SQL. But at the same time, QSQL as a syntax is not that far off. So I've seen many people that were more SQL oriented use QSQL very successfully. And now I think in one of the latest releases of KDB, you can actually use native SQL within KDB itself. So that has basically made that point moot. So it will be interesting to see how it evolves in the next 5 to 10 years. I would say how the cycle moves, but I definitely see a time where everybody was looking for the next technology to use, and it's going to be KDB, it's going to be Python, it's going to be something else, and the sprawling of many more offerings to then converge.
Yeah, it's interesting. Yeah, and like I think the SQL interface that came out was really about breaking down barriers to entry to like, so probably more for, you know, traders that have access to a KDB system, but they just can't get the value out of it or the data out of it, and they know SQL, so it's like, right, let's get them, you know, at least let them access it without having to do any transformations, and then obviously progressing to PyKX or Q, you know, as the option. But I think they're more like on the query side rather than like building your analytics suite with SQL necessarily wouldn't be suggested. But yeah, they're kind of, we're trying to, you know, if people need that to like start to understand KDB and use it and engage with it, like that's, you know, brilliant. Like we're happy to use that. But and that's why we, you know, we want to bring it to more audiences and more users out there as well. And for these firms that do have them and places that you do use them, like open it up to the other users in there. So it's not just a small group of KDB developers that can, you know, build reports or create analytics out of the data. I think that's been really important.
Let me flip the question to you. What have you seen as a change in the last, let's say, 10 years?
Good question. Back to me. Yeah, I guess I haven't been in the field in a while, but I do think what you said on, you know, the Python, you know, change and you know, so many developers now, like, I mean, anyone doing computer science or computer engineering degrees, like in my day, I was all like Java and C++, but like now it's the de facto Python that you're going to come out with. That's what the next generation, that's their first language of choice, it seems. And I think the more that we can do to engage with that user base and make things easier for them. And we do have some really exciting releases coming up in the end of the year, October, November time on the PyKX front, that are going to, I think, really excite a lot of Python audiences and to be able to bring our technology to them even further. So yeah, that's one thing I think has changed a lot. But yeah, if anyone has any other things they've seen, do let us know in the comments as well. Anything else you want to talk about? I guess, is there one, like, I mean, if we like had to summarize or say, is there like one big challenge across all of quant research that when you know, you get new clients or see people come to you, that people like underestimate, you know, how difficult it is, or, you know, how is there such a thing as that, or is it all, you know, people understand that it's going to be difficult and tricky, or, you know, maybe it's, you know, people think they can do the whole thing in Python and then actually they do build it and then they have to end up rebuilding it and going down that path. Is there any advice maybe that you'd give to someone starting out?
If I were to think of something, top of mind would be perhaps to not get too bogged down into the technology. Don't start approaching from the technology, right? Because that's a rabbit hole that is very hard to escape from. And what I mean by that is, if you're saying, okay, we're going to do quant research, we're going to do a MACD, for example, as easy as a MACD indicator in real time. You can build it in any number of technologies that are available to you right now. And so I would say really think instead about what is the business and where that's going and why, and use that to make the determination as to, okay, so we're doing MACD now, and where is that being served? Is that going to a UI? Is that going to be displayed in a table on this so that other people can use it after? Is that going to go into a real-time alerting system? Is that going to go to a streaming platform that then fires up alerts whenever, you know, something happens as a trading signal? I think that's more of the approach that I would follow, as opposed to just say, oh, will I use KDB because it has pre-built VWAP, or will I use Python because I can copy paste of ChatGPT to automatically indicate? I think that's a very slippery slope that I've always tried to steer away from. And I always tell the same to people: don't use the technology as a reference, but talk about the business problem, and then choose the technology that is more there's accepted and embedded in the culture of the business that you're really in, and that's the way to succeed. Then you can innovate either way.
That's a really interesting perspective. And when people are like, oh, you should use KDB because it's the fastest, well, that might make sense, but not always. So yeah, looking around your stack and seeing upstream and downstream, and maybe you use KDB for some of the stuff, and then for other things it doesn't make so much sense if you're serving it up in a certain type of UI or report that is better suited with a different technology. We have another question here from Max. How does the maintenance of KDB code compare to maintaining Python code? Things such as specifying and updating dependencies, for example.
This is a very touchy point, for sure.
Carefully.
Oh, absolutely. Especially because it kept me up at night multiple times. So either side of the technology. So let's make no prisoners here. But I would say the simplicity of Python in that comes in all the ecosystem, and you might have modules that will help you be more keeping track of what packages you're using, what wheels, and what version that is. There's more of a version concept built in that. You have tools that allow you to select those, right? And you have more of a community that may tell you, okay, so this very version of this library is not good. You have to switch, and then you have to go and update your requirement TXT and just do it from there. Whereas in KDB, it's a bit more ad hoc, in the sense that if you're loading a library, it's most likely an internal library more so than an external one. So you would follow that process differently. But also, as I said earlier, there's less code to be updated, which to me it's always been the appeal. And so if you look at this historically, for example, two big events in the history of KDB, I've actually proven this point. One was switching from 32-bit integers to 64-bit integers, where now people actually had to go and change all the defaults that they were using in their code, because if you used an undeclared number, that would come up as a long instead of an integer. Now all of a sudden memory was a question, right? So we're doubling up our memory utilization across the board. Does math perform the same across the 64 and the 32? So those are things that you have to go. And another one was a bit further away, where how you look when you do docu.meta, that tells you the definition of a table, for example. The most recent versions look at the most recent partition in your database, whereas prior to 2.4, if I'm not mistaken, it would look at the oldest partition in your table. And so when that switch happened in the technology, you would see people that would go and override the function with their own definition. You would see behaviors across, let's switch to the newest, let's switch to the oldest, let's build our custom one, which is something that you wouldn't see in Python as much because of probably a more complete ecosystem around management of dependencies.
Yeah, and it's not, we wouldn't say it's necessarily a bad thing, it's just a consideration that,
I think it's just a consideration of the technology itself, and it's very different across the two.
Yeah. Awesome. Okay, I think that's probably a good place to wrap up our session today, just given the time we're at nearly. But if anyone does want to continue talking to me or Emanuele in the chat, please sign up on our Slack community. We just launched it a few months ago, and you can chat to KDB developers over there and get all your questions answered on anything KDB or quant research or anything you want to continue chatting about over there. And just a huge thank you to Emanuele for sharing his insights today. I couldn't have done it without him and all of his experience. I really learned a lot today, and I'm sure our attendees did too. Also, if you're not already following Emanuele on LinkedIn, you really should, because he puts out so much great content and tips and tricks, like daily, if not weekly, or weekly, if not daily, that I see all of your great stuff coming out. So I would definitely recommend following him over there. And yeah, I hope everyone found it useful and learned something today, I will be hosting more LinkedIn live sessions just like this one, talking to other users and experts. So if you have any suggestions for what you'd like to see covered on those, or if you want to come on and join me, if you're brave enough, just reach out on Slack or just DM me on LinkedIn. But yeah, that's it from us today. Until the next time, thank you so much for joining, everyone, and take care. Thank you.
See you.
Bye. Bye.